Hello, welcome. Our targets for today, we will be solving exponential equations by finding a common base and by taking the log of both sides. And we'll also evaluate logarithms using the change of base formula. So first, if we want to solve this equation for x, hopefully you can see that 9 would be 3 squared. So I could rewrite this as 3 squared x plus 1. Now these two have to be equal. So x minus 2 has to be equal to 2x plus 1. Now when I multiply over the parentheses, x minus 2 is equal to 2x plus 2. And now I would subtract x from both sides, leaving negative 2 is equal to x plus 2. Subtract 2 from both sides, so negative 4 is equal to x. So that is our value of our x in this equation. Now see if you can do this one. Pause the video and see how far you get. All right, hopefully you're done. 2 to the third power is equal to x plus 6, and this is just 2 to the 5x. Since we have the same base, these exponents must be equal to each other. So now I distribute over the parentheses. So this would be 3x plus 18 is equal to 5x. Subtract 3x on both sides. So this would be 2x. And now x will just equal 9. All right. Now if I want to solve x here, now we have to think, is this 7 to some power? 7 times 7 is 49. Multiply that times 7, you get 343. Multiply that by 7, and you will get 2,104. So if 7 to the third power is 343, and 7 to the fourth power is 2,401, we know this x value has to be somewhere between 3 and 4. But it's not exactly 3 or exactly 4. So we need to think of a new method for doing this problem. Well, one thing we can do to both sides is log both sides. So I can take log of 7 to the x power times log of 983. Now there's a rule that if we have an exponent, we can bring it out in front. So this would be x log of 7 is equal to the log of 983. So I just divide both sides by the log of 7. And I have x is equal to, well, if I use my calculator here, I can say the log of 983 divided by the log of 7. That will equal 3.541. And that is my value. And notice how we were right. It was between 3 and 4. Turned out really close to being halfway in between there. All right, now let's look at this. 6 to the 5x is equal to 1,300, or 1,032. So what I would do is log both sides. Log of 6 to the 5x is equal to log of 1,032. So 5x times log of 6 is equal to log of 1,032. Divide both sides by the log of 6. So I would still have 5x is equal to, let's see what this is, log of 1,032 divided by the log of 6. I get 3.87. 3.873. And now to solve this, I need to divide by 5 on both sides to find my value for x. So my x value is going to be 0.775. All right, so hopefully this is making sense to you. In this one, now this 3 isn't attached to this, so before we start our problem, we want to divide by 3. So I have 1.5 to the x power is equal to 17 thirds. Now I want to take the log of both sides, so log of 1.5 to the x is equal to log of 17/3. That x comes out front. And what we like about that x coming out in front, now we can divide by log of 1.5. So I have the log of 17/3 divided by the log of 1.5. So log of 17/3 divided by the log of 1.5, and my answer is 4.278. Now, this gets a little bit more complicated. Take a second and see if you can do this on your own. Pause the video and see how far you can get. First thing I would do is subtract 8. So 1.8 times 4.7 to the 2x. This would be 13. Now we want to get rid of the 1.8, so I divide by 1.8. So I have 4.7 to the 2x is equal to 13 divided by 2.8, which is 4.643. Now I'll take the log of both sides. So I have the log of 4.7 to the 2x is equal to log of 4.643. Now I'll pull that 2x out in front. Now let's find the value of x. Now last time I divided by the log of 4.7, but really I can divide by everything that I want to get rid of. 2 log of 4.7. And that'll get rid of the 2 and the log of 4.7, and it saves me an extra thing to do. So now when I divide this out, my x value is equal to divided by 2 times log of 4.7. I got 3.454. 3.54, nope, 3.454. And that is my value for x. Alright, so here's a situation. The number of certain species of fish, N of t, is measured in millions. At time t in years is modeled by the function N of t is equal to 12 times e to the 0.012 t. What is the initial number of fish? So initially, time is equal to 0. So N of t is equal to 12 times e to the 0.012 times 0. Well, 0 times that is 0. E to the 0 is 1. 1 times 12 is 12. So 12, I should say, million, because it's measured in millions. The initial number of fish is 12 million. How many fish will there be after 15 years? Well, I just plug in a 15 here. So I take 15 times 0.012. I get 0.18. And then now I have 12 times e to the 0.18. Now there's a nice e button on your calculator when you hit second natural log. And if I could just type that all in at once, and so I'd get 14.3666. So that's then 0836. So that's 14 million. So 14,366,608. Now it says round to 3 decimal place. I think they're just talking right here. 14.3667 millions. But since we have the numbers, might as well write it all out. The number of certain fish are measured in millions, modeled by that equation. Algebraically find the number of years until the fish population reaches 30 million. Now we'd say 30 is equal to 12 e to the 0.012 t. So the first thing we do is divide by 12. So 30 divided by 12 is equal to 2.5. is equal to e to the 0.012 t. And now to get rid of an e, we do a natural log on both sides. So natural log of 2.5 is equal to the natural log of e to the 0.012 t. Now natural log of e to this is like saying e to which power is e to the 0.012 t, which those things cancel out. It's just 0.012 t is equal to the natural log of 2.5. So I'll just take the natural log of 2.5 and get that answer, which is 0.916, and then divide that by 0.012. So my time is 76.358. That's how many years it will take before it reaches 30 million. Now, if I wanted to find a log base 7 of 43, what I could do is say 7 to which power is equal to 43. Take the log of both sides, pull that x out in front. Now I divide by log of 7, so the log of 43 divided by the log of 7, and then we would get some number, log 43 divided by log of 7, 1.933. Now, let's look at this. How can I get from here to here? So if I had log base 8 of 40, I could go through all this process again, but I'd really just be taking log of 40 over log of 8. It doesn't take doing too many of these before you just skip out of this whole process and go straight to finding the answer. We call this the change of base property, and you can do it with any base. You just take the log of the top of the x value over the log of the a. Now, if I wanted to do something different here, since I said you could do it with any base, if you wanted to try this in your calculator, if you did the natural log of 43 over the natural log of 7, you will still get 1.933. So whatever base you want to use, you're more than welcome to use. So in this one, we take the log of 23 over the log of 4. Or in this one, we take the log of 19 over the log of 7. This one, we take the log of 21 divided by the log of 9. Now to find the correct answer, I'd say log of 21 divided by log of 9, and I get 1.386. Log of 78 over log of 4, log of 78 divided by log of 4, I get 3.143. Log of 19 over log of 2. Log of 19 divided by log of 2, 4.248. All right, hopefully that's enough to get you through the homework for tonight. Good luck.